Okay, let's do problem 19, remove nth node from end of list. So in this question we're given a singly linked list and then n, which represents the nth node from the end of the list that should be removed. So n is equal to 2 in this question, so we remove this one and then link this. So there are two things we need to know. The first one is when it ends, when we need to detect end of list. And since we're removing 4, it would be great to know the one before the node. We need to know node before the one to be removed. And then if we look at example 2, head also can be removed. So we need to create some dummy node here. And then at the end of our operation, we can just return dummy.next. So the question is, how far should they be apart, these 2 pointers? Well, n was 2, and then look at how many nodes they are apart. Well, because this is pointing at null, so they are actually n apart. And we can call them slow and fast. And we can initially put the 2 pointers in the pointing to dummy, and before we do anything we can move the fast pointer so that slow and fast is n apart. So we have list node of dummy equals new list node of 0 and head. And then we do need list node of slow equals dummy, list node of fast equals dummy. And then we can do for int I equals 0, I is less than n. So if we do less than n, so we have slow here and then fast here. If we do n, I is less than n and then n is 2, that means fast will move twice, but they are only 1 node apart. So this one should be I is less than or equal to n, and then we do I plus plus, and then we simply move fast by 1 for each operation. And then while fast is not equal to null, we simply move both slow and fast by 1. And now that is what we have. So slow will be here, fast will be pointing null. So slow.next should be slow.next next. So we're basically skipping one. And then we return dummy.next. Let's run the test. Let's submit. Okay, that's it.